Hey everybody, we're on to 7.7a exponential growth, and we are going to model exponential growth. All right, talk about what it is and then an example of it in real life. So, exponential growth occurs when a quantity increases by the same rate in each time period. So, it's an exponential function, but this is when it would be an increasing exponential function. It's growing. Okay, so here's an exponential function. Yeah. Y equals a times b to the x. All right. That's an exponential function. In order for it to be exponential growth, our b value has to be larger than 1. So if you're looking at your b value, the number with the base with the exponent, and that's bigger than 1, it's going to be growth. Exponential growth, that is. Okay. So since exponential growth always has a b larger than 1, you'll often see it written as y equals a, right? And then this will be 1 plus r to the t. They change the b and make it 1 plus r, and they change the x to a t because often exponential growth will be kind of as a form of time. All right, over time. So y is going to still be our final amount, a is the original amount, but r is going to be the rate at which something grows, at the rate of growth. Usually it's a percent, but we need to convert it to a decimal. And lastly, T stands for the amount of time. All right. Most of these are going to be, like I said, over a period of time. So here's an example. The original value of a painting was $9,000 and it increases by about 7% a year. First, write an exponential growth function to model this. That's what you have to do first. Just write the model, then find the value after 15 years. So the first thing I'm going to do is base it off of this. All right. I'm going to plug in my values that I have. The one I'm not going to plug in though is the 15. All right. It's weird. No, I am going to plug in the 15. No, I'm not. I shouldn't have that 15 there. Mr. Stanwood, you silly. This should just be a T. All right. Because if I want to just create a function for this situation, it's increasing 7% a year at $9,000. It's going to be not y equals 9,000, which is my initial value, times 1 plus 0.07, because that's the percent, to the t power. That represents this situation for any amount of years. Now, what I want to do is find it, well, in 15 years, what I'm going to do is now I plug in the t for 15. I got ahead of myself there. And I'm going to enter that in the calculator, 9,000 times 1.07, because I can add them first because the parentheses to the 15th power. And that gives me $24,831.28. That's a lot of growth. All right. It went from 9,000, 15 years later, it is at 24, almost 25,000. And that's exponential growth. Now, a common application that you're going to see is this thing called compound interest. All right. You worked with simple interest, I believe, in 7th grade. It's I equals PRT, interest equals principal times rate times time. Compound interest, well, this is you earn your interest on both the money that you put in and on the interest in there. So compound interest is what most banks actually use. So this will come in handy later on in your life. And maybe you might be talking about this in some of your some other classes, maybe some STEM classes. So here is the formula for it. All right, I'm not going to stay on here too long because I'm going to have you pause it and copy all this information down. All right, but A is going to be your overall balance. P is the principal, the original amount. R is your interest rate as a decimal. N is the number of times. Oops, let me move myself. That it is compounded per year. I'll go on that on the next slide. And T represents the time, always in years. Pause it and copy this stuff down. So now these are your N's. All right. If it says it's compounded annually, compounded means, I guess I should backtrack. I apologize. Compounded means that's how often they will give you more money. I'll put it that simple. All right. If it's compounded annually, they will add interest at the end of the year. So your N would be 1, just 1. If it's compounded quarterly, quarters are 4 times per year. Monthly, there's 12 months in a year. All right. If it's compounded weekly, what would your N be? Hopefully you said 52. All right. So there's all different amounts that it could be compounded. So let's write a compound interest function to model this situation. Then find the balance after the given number of years. So here's my basic A equals Well, here it is. I'm just going to now identify all of the right parts. All right. P, my 1200 is my principal, my initial amount, 2%. That's going to be my rate. It's compounded quarterly. Quarterly will be 4. So my original function is going to be this. All right. It's going to be 1200 times 1 plus 0.02 over 4 times 4 to the t. All right. This is going to be my original equation. And then now I want to find it after 3 years. So what I'm going to do is my t is 3. I'm going to change this 4t into, now it's going to be 12. Okay. And what I'm going to do now is just carefully enter that into the calculator. Here it is, the formula here. And I get about $1,274.01. All right. That is one example. I'm going to do another video with more examples if you want to go in more detail with this. But for now, here, that one, do that one, do that one. For now, if you feel good, you can try out the IXL X6 and your mastery check.